Who would like to do the prayer to start the session?
Dear
Yeah,
God,
thank you. You can unmute, sir. You unmute. Yes.
dear God, I place my humble needs before you. My need to meet my responsibilities in the world. My need to use my God given talents and abilities. My need to fulfill my place here on earth. I pray for your guidance now to show me the way to the perfect opportunity to do what I love, to do what I can do well, and what will fulfill my needs mentally, spiritually, and financially. Help us to walk in faith as you show us the way. I'm praying for everyone in the universe. Let them be safe, happy, peaceful, and healthy. Thank you, God.
Thank you
Thank you.
so much for accepting immediately and doing the prayer. Happy, happy. Okay.
Thank
I'll
you.
move the first slide. This one. Before get into that, because you have still 3 more minutes, because informal talks I can complete in the workshop. Rightly, it start by 7. As you know well, this program, our instructor is Mr. Sujit. Okay, he is a technical educator from Inspired team, and he has done more courses. Like no, more courses in the sense he has not got certified. He that is promoted many courses in Udemy, and he did for that is assembly language, machine learning, and C programming, Java, so many, much more, and a very nice person, and I know him like I just connected with the past 2 years only, but still very friendly person and more interactive. And one important thing is he's ready to share the knowledge with you, and you can connect whenever it is required. No, you can just raise your hands and then or you put it in the chat box and you can talk to him. You can unmute and talk to him. He's definitely will help you with your queries. Okay, it's full and full. It's a hands-on session, and it will be more useful and interactive. Okay, right? And Sujit, can you, Sujit?
Yes, ma'am. I hope I am audible to you.
Yes, yes, you're audible. Yeah, and make it more great workshop. And I welcome you
Sure.
all again on behalf of Inspire. Okay. So lighting is not good. Sujit is a bright person only. Instead of light on, he looks dark. So no worries. Okay. Right. People, all the very best for the wonderful learning and happy learning journey of this 3 days workshop. Okay. And Sujit, you can have an informal talk with the participant, and then you can go ahead with your thing. When at least first 2 minutes, just talk to them informally. Then go ahead with the workshop.
Yeah, sure, sure.
Kitchen.
Sounds good, ma'am. Thank you so much. Hey all, first of all, many thanks for you to attending this workshop at this moment. You could have planned something else, right? Some entertainment stuffs, but at this moment, you have spent this amount in order to make time, fruitful for you, right? So I assure that time will be fruitful for you for the 3 days, in which I'm going to teach you the concepts of ML and the implementation as well, right? I hope my audio is very clear. If you face any issues in my audio, please do let me know. And whenever you face any doubts, or if you have any queries, you can ask me through the raise hand button, which is available to you digitally. So I would request all the participants to turn off your video and mute yourself. And whenever it is required, you can unmute and ask me the questions. Right. So before starting, let me introduce myself. I'm Sujit Kumar, and I'm a freelancing course instructor. I do freelance courses in the field of machine learning, Python programming, deep learning, artificial intelligence, C programming, C++, Java, object-oriented programming, and I am basically from electronics and communication engineering background. So I do teach courses on embedded systems, digital VLSIs, and analog
Can you
circuits
switch
as well.
on your video, please, sir?
Actually, sir, since my router is connected in this portion, my face would look dark if I switch on the video actually. I'll
Just a
make sure I'll
moment,
switch on the
you can
video.
switch on for your sake and then you can switch off, Sujit.
Okay, sure.
Yeah. Just a moment. You just show your face and then you can
Yeah,
off
ma'am.
your video. Yeah. Hmm. Because you could figure out only the shape. That's why he was telling.
Yeah.
Okay.
Just my router is connected here. That's why I'm sitting
Yeah.
in this
Understood.
direction. If I
Understood.
sit in the opposite direction, maybe
Yeah.
my face would be
Understood.
visible.
You proceed. Proceed, Sujit. Yes.
Yeah. Right. So yes. So in this session, we are going to start the session from the basic concepts of ML, and we will slowly see the mathematics behind the ML algorithms. Before that, I would expect you to have some review on the basic statistics and the mathematics. And of course, we are going to implement ML algorithms. For that, we'll be using Python. And I'll be asking some questions in Python. If you can answer them, like I'll just leave out the basics of Python and I'll go directly into the implementation of ML algorithms using Python. Otherwise, we will have a recap of Pythonic concepts as well, and then we will move on to ML. So it's going to be a hybrid course where we are going to study machine learning, some basics of statistics, Python, and the implementation of the algorithms. So we'll be covering all the aspects so that once you complete this workshop, you can go and implement ML algorithms for your own applications. Okay. So ML is kind of a general domain which can be applied to your own domain. For example, if you take myself, I'm basically from electronics and communication engineering background. So I do use ML for my own application to design digital circuits, maybe, right? I'll tell you the procedures in which you can use ML, maybe to predict weather forecasting if you are from that domain, or to predict the health of a plant if you are from biology, maybe. So that's where you can integrate these cutting edge technologies with your domain in order to move towards a more accelerating future. So that's the basic idea of learning these cutting edge technologies, right? Yes. So we are basically what we are going to learn is the applied machine learning, right? I guess I got a question here. Can you please teach all from basics? I'm new to all like these except statistics. You need not worry about it. We just have a very clear mindset. It is okay to don't know anything. Okay. I'll teach everything from the basics, not only the terms and terminologies and also the basic concepts of ML. But I would request you, if you already know these concepts, initially we'll be teaching some basic concepts. If you already know these concepts, please tolerate up to some extent so that we can actually jump into the like the algorithmic implementation, right? All right, to save my bandwidth, I'll turn off the video and move into the slides. Uh, okay, thank you, Mr. Vishal. I hope that my screen is visible. Uh, can I get an acknowledgement from any of you?
Yes, the screen is visible.
Yeah, thank you so much. All right, so first, again, once again, welcome you all to this workshop, machine learning a deep dive. All right, so we will be starting with the basic concepts of machine learning in this session, some basics of statistics, the terminologies involved in machine learning. So that is what I'm going to cover in today's session. And if we have some time, we will learn Python for data science as well, right? And there is a task which have to be completed by every participant in order to avail the certification, right? And that will involve implementation from the scratch. And I'll be helping you for that implementation, right? Before that, we will understand the maths behind every algorithm. That is how the algorithm actually works. Okay. I won't stick on with the slides. Don't worry about that. As whenever I need the whiteboard, I'll use that and I'll come back here. And whenever I need the coding environment, I'll go there and teach that. Right. All right. Okay. Let us start with the basic thing. So where the machine learning actually fit in this world. So in this world, there is the field of artificial intelligence. All right. So artificial intelligence is making machines to think without any human intervention. That is what given in the slide, right? So basically the AI is a very broad field in which we give some kind of intelligence to the machine. So since that intelligence is man-made, okay, it is not given by the God, it is man-made. We call that intelligence as artificial intelligence, right? So basically, the machines which have this artificial intelligence, we usually call them robots. All right. And machine learning is actually a subset of this artificial intelligence. All right. So machine learning is again making machines think only, but in this machine learning, we'll be using some statistical learning algorithms. All right, some mathematics. Okay. So I'll tell you what are those algorithms. So we will understand that we will use statistical algorithms to learn the data, right? To learn the data over time. So machine learning is going to be a subset of AI. In machine learning also, we are going to enable machines to think, but we are going to use statistical algorithms. So that is the only difference. And deep learning is again a subset of machine learning. So deep learning can be used whenever the problem gets more and more complex and you need to arrive at the solution at the expense of complexity. So in that case, you can use deep learning, right? So it's going to use multiple layers in order to filter out your data. So all these terms are somewhat hot terms, which are the cutting edge technologies. People used to call them as cutting edge technology. So how can you clearly differentiate them? So AI is a broad field. Machine learning is a subset of AI, and deep learning is again a subset of machine learning. In other words, I could say that whenever a problem that is cannot be, if that problem is cannot be solved by machine learning, you can try that problem with deep learning, right? So what is machine learning? So basically, when you say learning, what is learning actually? Learning is gaining knowledge, right? So gaining. So what is kind of the source for learning? So when you learn something, there must be a source, right? So basically, there are various sources for us to learn. Let us think a human must to learn. Human must learn. There are various sources of learning available. We can learn from books, can learn from videos, we can learn from music, movies, etc., etc. The one important thing is we can learn from experiences, right? So what we experience in day-to-day life. So that's how human brain works. We will learn automatically from experiences and also the data, right? We are going to apply a similar approach for the machines as well. The machine is also going to learn, but from the past, the data, right? So basically, it's not a magic. Let me put it in this way: you have some kind of data, some data that you give it to a machine. The machine will try to understand the pattern in the data. That's all, using some mathematical algorithms, basically mathematics. So machine will try to apply some mathematics on the past data so that it can predict what will happen in the future. So it's purely mathematics. It's not a magic, right? So the based on the quantity and the quality of the data, you can determine the accuracy of any machine learning model, right? So that's very important sentence. The quality and the quantity of the data is going to dictate your accuracy, right? How accurately the model gives you the predictions, right? All right. So this is kind of a general definition for machine learning. People used to say it is a field of study that gives the computers the capability to learn without being explicitly programmed, right? So the idea is the computers are given the ability to learn. I repeat it. The computers are given the ability to learn and they are not being explicitly programmed to do this. Basically, the computers will execute whatever we feed to them, right? So basically the program, maybe C or C++ or Java, whatever it is, whatever we provide as a program, the computer will try to execute them step by step. It's a sequential execution unless and until you have multi-core processors, right? And but in this case, in machine learning, it's the opposite way. We give the computers the ability to learn. All right. So it is not by mathematics, through mathematics. So ML is not magic, but mathematics. Right. Okay. So let us look at a very simple example to understand ML, a naive or a noob example, maybe. Okay. So please follow me carefully. This will give you an intuition of machine learning. Let us take an input and output, right? So basically, any machine learning model, if you take any machine learning a system, I could say, it is going to learn the pattern between the input and the output. Okay, so you give input and you give the output as well. You say what is the input and what is the output. The machine is merely going to learn the patterns, okay, or it's going to relate the input to the output. That's all, right? And once it has got the relation, you can use that relation to predict for your future. That's all. So machine learning broadly can be defined as arriving at a relation by looking at the input and output. Okay, so you give both the input and output. Let us take this example. When you have x, I would say y equal to 2. All right, so when x is 1, let us call y equal to 2. When x is 2, let us say y equal to 4. When x is 3, that means your input is 3, let us say y equal to 6. The question is, when x is 4, what is y? Can anyone?
8.
Yeah, so it's 8, right? It's pretty straightforward. When x is 4, y should be 8. But why? Why it is?
Like the input is multiplied with 2 and you get the output.
Yeah, so that's how we infer from the data. It's very simple. You look at the data and you infer something from it, right? So actually what you got is the very right inference. Input is multiplied by 2 and that becomes your output. The machine is going to do the same. It is going to look at the data and it's going to infer something from it. That is what machine learning is all about, right? And, okay, I could see a voice. Does anyone have any doubts in this? All right, thank you. I could see some vibrations in. All right, thank you. So exactly, I'm coming back to this. So you give the input as well as the output, and immediately your brain tries to understand the relation between them, and you can now, if I say any value, you will be able to tell the y value, right? If I say any x, you'll be able to give me the y because you know the relation. That is what machine learning is all about. Based on the data what you give, it is just going to understand the relation between the data, right? Y equal to x. So it's basically trying to form that function y equal to f of x. Basically, in this case, it is y equal to 2x, right? Because y equal to 2x. Why it is y equal to 2x? Your x must be something, and that should be multiplied by 2. That is becoming y. Okay. Is it so? Is it visible? Does anyone face the same problem? Anyone else? Okay. Thank you, people. I guess, Mrs. Shanmugapriya, I think that's a problem from your side. I have to check it out. All right, thank you so much, people. Thank you. So let us come back to this. So by seeing this data, you are inferring something, and that is going to be the equation from this data, right? Once you have this equation, you are assured that if you give any x value, you can find the y value, and that you can call it as prediction. Give any x value, I can predict the y value once I have understand something from the data. Once I have understood something from the data, given any x value, I can give you the y value, right? So this is what inferring is all about. This is what machine learning is all about. You are trying to form an equation from the data, right? More generally, you can give this equation as y equal to ax plus b. Okay, ax plus b, where a and b are the coefficients. Here in this case, a equal to 2. You just follow my mouse cursor. A equal to 2 and b is 0, right? But how do you know a equal to 2 and b equal to 0? You have to understand the data. You have to understand the data, the relation between the data, relation between the input and output. Then only you can arrive at this relation, a equal to 2 and b equal to 0, right? So this is what learning is all about. The machine is going to learn only these coefficients. What if I say that you are going to fix that equation, y equal to x plus b, and the machine is going to learn only these coefficients, a equal to 2 and b equal to 0. So if you change this pattern, if you change this data, your a and b value will get changed, right? So the machine is going to learn this. Okay. So what is the advantage of learning this? You may not be getting this, right? What is the advantage of learning this? See, For 4 data points, for very 4 samples, I could call this samples. For only 4 samples, if I could arrive at a relation, like this, you can give me 100 unknown samples. What do you mean by unknown samples? Which I don't know the output, for which I don't know the output. You can give me 100 unknown samples. I'll substitute in this equation and I'll give you the output, right? That is what prediction is all about. So inferring from the data is machine learning. Fine. So these A and B coefficients are there, right? These coefficients are called as weights. Okay, we basically call them as weights. It's a very common word that we use in the machine learning domain. Weights. Okay. Basically, we train an ML model. This is called training. Okay, making an ML model, learn all these, learn the relation between the data is called training. So we train an ML model and finally we find out what are the weights, and we will store the weight somewhere, which can be used in future for prediction, right? So arriving at this relation or inferring from the data, the inference is what you make from the data, will be helpful for future prediction, right? So this is a very simple example to understand. Okay, am I clear in this example? Is it unambiguous? Is it okay? Very simple and very naive example, not so advanced or in depth. Am I clear in this? Please use chat box to respond. Yes, thank you. Thank you so much, people. Thank you. Right, so we will move on. I hope it is interesting. We'll move on. All right, so it's kind of some memes. Let us see to give you a good understanding. So the equation what you see in the screen is, right, y equal to bx plus epsilon. So the same equation, guys, y equal to ax plus b, and you can call a and b in any terms you want. Some people would call it y equal to mx plus c. Some people would call it y equal to beta 1x plus beta naught. Some people would call it y equal to beta x plus epsilon. They all mean the same. This is a linear equation, that's all. Okay, doesn't matter in which terms you will call it, right? So in 10 years before, it is called as statistics, and now people try to call it machine learning. Okay, 2019, people just try to call it machine learning. Yes, so the crack in this wall is statistic, and you place a frame over it, just a frame, and people started selling it as machine learning. That's all. Thank you, sir. Thank you. Right. So this is what machine learning is all about. It's just mere statistics which you have to understand. That's all. Right. We'll dig deep into it. We'll see what are the statistical algorithms. Before that, we'll see the difference between the traditional approach and the machine learning approach, right? I mean, the traditional programming and the machine learning approach. So in traditional programming, what you will do is, so let us say you have your system, basically your computer, right? You will give your input, or give me a minute, it's not working. So you will give your input, you will give the program as well. So write a program and give your inputs. So the program can be like, say for example, adding 2 numbers is my program. I'm writing a C program to add 2 numbers. Then I will give 2 inputs to that program, A and B. Basically, what you expect from the system is to produce the output. That's all, right? So you give the program and you give inputs to that program. What you expect from the program is the output, right? The program must be applied on the input and outputs must be produced. So that is what you expect from the, this is the traditional programming way or conventional programming way. Just a minute. Give me a minute, people. This board is not working. Yes. So this is your conventional programming. Whereas if you take an ML approach, what we will do is we won't write the program explicitly. We won't give any C program. In this case, in this traditional programming case, it is very much clear. You write a C program to add 2 numbers and you give the inputs like A equal to 5, A equal to 5, B equal to 6. So you write the program, you write the algorithm. So the output must be 11, right? So adding 2 numbers. So 6 plus 5 must be 11. So you expect the output by giving the input and writing the program. There is no intelligence involved here. No intelligence, right? You just give the input and the program. The program has to be executed on the input. That's all. No intelligence at all. Whereas if you take an ML approach, you apply the input as well as the output, right? So you give both the input and output, similar to what we have seen before. Like we have seen an example, right? Y equal to 2x, something like this. We are not going to give the relation. We are going to give the input samples and the corresponding outputs, right? So I will say the machine that this is my input and this is my output. You just learn the relation between them, and the machine is going to provide me the inferences or the learnings in terms of weights, which I told before, in terms of weights. This is what we mean by machine learning. This is what we mean by machine learning, right? So for example, if I take let us say my inputs are 1, 2, 3, and 4, and my outputs are 2, 4, 6, and 8. Okay, so this is my input and these are my outputs. That means for 1, the output is 2. If I give 2, the output is 4. If I give 3, the output is 6, and if I give 4, the output is 8. Then the inference would be y equal to 2x, right? So this is the inference or equation, and the machine is going to produce only the weights, right? So a equal to 2, b equal to 0. These are my weights, right? These are my weights. So this is what we mean by ML approach. So this is how it differs from the traditional programming approach. In traditional programming approach, you write the program and you give the input. You expect the computer to produce the output. But in machine learning approach, you give the input as well as the output. You define both the inputs and outputs. You expect the ML model to learn the relation, to learn the pattern, to learn the relationship between the input and output and produce some inferences. Because by learning, when we are learning something, we should be able to infer something, right, from the learning what we have made, right? So this is what an ML is all about. Okay. Similar to how humans work, guys, because let's say if you are learning an equation, if you are learning some formula, then what is the objective of that learning? We should be able to solve problems using that learning, right? So that is the inference. So any learning should have an inference. If there is no inference from the learning, that is not learning, that is studying, right? That's different. Okay, so this is how an ML approach should work. Okay, you give the inputs as well as the outputs, and then you make the ML model to learn the inferences. Okay, right. And the inputs, what you are going to give to the ML model, technically they are called as features. Okay, features, or you can even call it as independent variables, right? Independent variables. And the output, that's also should be given by you only. The output must be called as target or dependent variable. So I will use these terms independently. Okay, don't get confused. Whenever I say target, I mean the output, and features are my inputs, right? Okay, fine. So for example, for 1,000 samples, if I give both the features can be more than one. Inputs can be more than one, guys. X1, X2, X3, multiple inputs can be there, multiple features. And let us say there is only one output. Outputs also can be of n number, but let us take only one output. So you have multiple features and one target. Okay. And for 1,000 samples, I know the input as well as the output. I know the input as well as the output for 1,000 samples. So I will make a machine learning model to learn these completely, right? To learn the relation between y equal to f of x1, x2, x3. I basically make the ML model to learn this function, right? To learn this function which will relate the target with the features, I repeat it, right? Which will relate the output with the input. So once we have learned everything, now let us take at unknown sample, let us take some A, B, and C here, for which you don't know the output. Some unknown samples, right? Some unknown features. If you give these features to the ML model, if you give these features to the ML model, since the ML model has already learned the function from the labeled data, it has already learned the relation, it will be able to predict a Y. It will be able to apply that relation on your unknown data, and it will give one Y, right? And that Y should be put here, right? Am I making it clear? Uh, is it okay? Yes, yes. Thank you, sir. Thank you. Uh, Thank you. Right, right. Thank you, ma'am. Thank you. So if you have any doubts, so please stop me at any point of time. Right. So, but you just have to remember this in mind. Inputs are going to be called as features. Outputs are going to be targets, and inputs can also be called as independent variable. That means here x1, x2, x3 are going to be called as independent variables, and y is going to be dependent because your target depends on the features, right? Your target is going to depend on the features. Your dependent variable is going to depend on the independent variable. That's why y is actually, the target is actually dependent. Okay, thank you, ma'am, thank you. So your y is going to be dependent. Fine. All right. So if that is the case, let us see one example. Let us see that, or let us understand that. I'm making an ML model. I'm making an ML model to predict the house price, right? To predict the house price. So what do you think that my features are? So I want to make an ML model. Anyway, I'm going to give a day. So it is dependent. Yes, yes, exactly, Ms. Bovana. Thank you. So let us come back to this particular example. I'm trying to build an ML model which will predict the prices of houses. Okay, house price prediction model. Fine. So basically, a machine doesn't know that what an house is, right? What is house price and what factors it's going to depend on, right? A machine doesn't know that. I'm going to make the machine to learn that. In that case, if I take a data set that will make the ML model learn about the house price, what are the columns of the data set? That means what are the inputs and what should be my output? Anyone guess? Can anyone guess? See, if I want to make a house price prediction model, I'm going to give data to the ML model. Okay. If I take that data, what should be my inputs? You can give any answers. What should be my inputs? And yeah, exactly, Mr. Afsal. Thank you. Area is going to be very important feature, right? Area is going to be a very, very important feature. Anything else? Square feet, that's again an area, right? That's again area. Square feet rate, again area. Previous year price. Location, I guess we can take locality. That's a good feature. Thank you. Square feet is again area. Environment, accessibility. Yes, locality can take 3 different values. Either rural, urban, semi-urban. Okay. Let us have it like this. Number of rooms could matter at all. Architecture, yes, you can include. Okay, so let us stop with this. So these are all going to be your features, right? Our input. So what should be my output? Output is straightforward. What should be my output? Anyone? So I'm making a house price prediction model. So output must be house price, definitely. Thank you. Right? So output must be house price. So this is my target. Right? Thank you. Thank you. Cost of the house. Yes, definitely. Thank you, people. Thank you. Thank you so much. Right. So if this is the data set, I must have at least 1,000 samples, right? Some number of samples. The more the number of samples, the more accurate your model will be, right? Both the quality and the quantity of the data set matters, right? So the quantity, it actually depends based on how much you collect. Okay. So for example, in one particular area, maybe 50 square feet. Locality is rural. Number of rooms, I have only one room. Architecture, I don't know, some values maybe. And price, let us take should be the price. Let us take 15L. Okay, okay, leave it, forget about it. And area is 100. Urban, and if I have two rooms, right, must be 60L, right? So I have some samples like this. I have some samples in my data set. If I give this to an ML model, the ML model has to predict the price, or has to learn the price as a function of all these features, right? As a function of all these features. But what could be those functions? What could be that relationship, right? It has to learn the relationship. One relationship we could obviously infer from this is, if I increase the area, if I increase the square feet, the price will also get increased, right? And for urban areas, the price will be more. Rural areas, the price will be less. And if I increase the number of rooms, and the price will also get increased. So these are the inferences, right? I expect the ML model to learn these inferences. That's all from the dataset itself. Okay, like how an human being is thinking of, right? So if I say that for 50 square feet, if this is the price, for 100 square feet, price is obviously higher than that, right? How do you know? You know from your experience. I basically expect an ML model to learn this. That's all. To learn this relationship. If I increase the area, the price will also get increased. And for urban, the price will be more. If I increase the number of rooms, the price will also get increased. So I expect the ML model to learn this linear relationship. That's all. That's going to be the function, right? So there are some mathematical procedures which the ML model will apply on the data set in order to learn these relations, right? That is, increasing price will increase area, increasing number of rooms will increase price, increasing locality will increase the, I mean, not increasing, actually taking urban or semi-urban will have more price comparatively with the rural areas, right? How can we relate all these inferences to a single inferences? Uh, I will explain the mathematical flow, Mr. Muhammad Irshad. So that will actually help you to get the intuition. That we will do. I'm just giving you an example to get an idea or hang of ML. Will that be fine? All right. So if I have to answer that question, basically it will be y equal to some beta 2 times x2, some beta 1 times x1, some beta naught times x naught. Let us assume like this. Assume that y is going to be your price, and some x2, x1, and x naught are your the features, the area, the locality, and let us say the number of rooms, some features, right? So this is basically the area, locality, and yeah, locality. The ML model should learn this weights, right? Should form a relation like this and should learn these weights. So if I say that if I increase the area, price will also get increased, means this weight will be a positive value, right? Some positive value it will be, right? And let us say if I decrease the locality, let us encode locality by a number. Okay, let us encode locality by a number, and let us say urban is 0 and urban is 0. Okay, rural is going to be 2. Rural is going to be 2. Then it means that if I increase the locality, that means since I've encoded it as number, right? So more number is given to rural. In that case, if I increase the locality, price should get decreased. Price should get decreased. So beta naught will be negative. Beta naught will be negative. So basically, I expect an ML model to learn these parameters. These are called as parameters. Parametric analysis they will call. So these weights or parameters, or coefficients in whatever way you call, these must be learned. Those values must be actually learned or gained from the learning. So this is what it does. Okay, is it okay? I'll explain an algorithm step by step in future, not now actually. You're seeing introduction to the machine learning. Is this okay? All right. So yeah, thank you, sir. Yeah, thank you. All right, now we will move to the types of machine learning actually. So there are various types of machine learning, which will be interesting. Let me tell you that. So we can basically classify ML into three different types. Okay, we can basically classify ML into three different types. One is supervised learning. Another one is unsupervised learning. And the third thing is reinforcement learning. Reinforcement learning is the formula seems to be a regression equation, right? Yes, what I have shown you is linear regression, right? So multiple linear regression, if I could make it clear. So there are several other algorithms as well. You have polynomial regressions as well. But I'm just talking about the introduction to machine learning. Okay. So that's why I've taken this very simple equation. But that varies. That varies. Actually. I'll show you some more equations. Actually. Yes. Shall I continue? Yeah, thank you. So I have three types of classification of ML: supervised, unsupervised, and reinforcement. All right. Basically, whenever you see an ML problem, you should be in a position to identify whether it is a supervised learning problem or unsupervised or even reinforcement, whether you can apply reinforcement kind of learning. So you should be able to classify. So I'll tell you some ways to do that. But the most traditional definition is in supervised ML, in supervised ML, we feed the inputs as well as the output. So basically, what we have been seeing, the house price prediction example, as well as the X and Y example, what I have told you, those are supervised learning examples, right? So in supervised ML, I feed the input as well as the output, right? But in unsupervised ML, I feed only the input because I don't know the output by myself. I don't know the output in the data set. I feed only the inputs and let the machine learning model decide the patterns in the input and cluster them, right? And group them, right? Okay. For example, when you see similarities in the data, those data will be grouped. I'll give you a picture of this unsupervised learning. But as of now, you understand that we'll give only the inputs in case of unsupervised learning. The data is unlabeled, right? Or in this case, the people call the data is labeled. Labeled means you know the output. You know the output. That's why it's called labeled, and this is unlabeled. Reinforcement is kind of a different way of learning, of machine learning, right? Reinforcement is one exciting area where you don't require much of data, right? You can learn in real time. You can connect the machine learning model with the environment itself. There is no need to have a predefined data set. There is no need to collect the data and train the model. You can directly connect the machine learning model with the environment, right? Let it learn the environment like how a human learns. Whenever you are joining a new company, let us say, you will go and in the initial stages of your work journey, right? For the first 10 days or 20 days, maybe you will be slowly learning the environment, right? You don't have a predefined book or a manual which will teach you or which will show you the work environment of the company. Only if you go and work for 10 days, you will get to learn that environment, right? So that's where reinforcement learning comes into picture. Reinforcement is where you connect the ML model directly with the environment. It can be any environment. People use this with robotics, where the robot is asked to learn the classroom environment, maybe the hotel environment, where you can make a robot to deliver the foods in the hotel, right? To a particular table, maybe. Then the robot will be asked to learn the hotel environment, right? So that's real-time learning. Okay, no predefined data set. That's reinforcement. I'll teach you how it works. Not into depth because we are focused on ML. Reinforcement learning is very, very recent. Okay, 2018 maybe, right? So now we'll see some examples. So in supervised learning, so this is a kind of the labeled learning, supervised learning, what I was talking about, right? Supervised learning, where you give the input and you give the output as well. That means these are my inputs, maybe. So apples. So I will tell the model that this is apple, right? So whenever I feed some inputs, I will feed the output as well in supervised learning. So I'll tell the model that these are apples. So the model will learn that, okay, when it is red in color, Okay, that is apple. Oh, great. So whenever I give an unknown sample, say what is this, the model will say that is it is apple, right? Labeled data. So I label these data as apple and I'll give it to the model, right? So this is what we mean by supervised learning, where your learning is supervised by your output, right? So you provide the output as well. Whereas if you take an unsupervised learning, we don't actually give the label. Actually, we feed the data as it is. So if you take these samples, we feed it as it is. So these samples will have apple and watermelon. Maybe the model will group them, will actually separate them, into different groups based on the features what we extract from the image, based on the features, right? Can you tell me one distinguishing features between these two labels? One distinguishing feature? Yes, classifying, exactly. It is classification only, but I'm asking about one distinguishing feature which distinguishes this apple and watermelon by looking at the image. Color, exactly. Thank you, doctor. Color. So when you take color, it's somewhat green in color, and the apple is red in color. So the machine learning model has to identify that particular feature, distinguishing feature, and it will group them, right? It will put all the red colors into one group and green colors into one group. It will never know that it is apple and it is watermelon. It will never know that. Fine. It will never know that. It will just group them based on the similarities, right? So since these 4 data points are similar, please follow my mouse cursor. These 4 data points are similar. They will be grouped into one cluster. Thank you, Ms. Bhavana. They will be grouped into one cluster, and that can be one cluster. It doesn't know that this cluster is apple. It doesn't know that. And these 3 data points are similar, and they will be grouped into one cluster. So that's how you separate them and you classify them. This is unsupervised learning, where you don't give the output. You just give the data and you make the model to distinguish the inputs into different clusters. Yes, so unsupervised learning algorithm, this is kind of distance-based clustering. Okay, so here you see these data points are closer to each other. So these data points can be made as a single cluster. So if I to take this, these data points can be made as a single cluster. Okay, no teacher is there. Sorry, hello, am I audible? Hello. Yeah, I'll get back to that. Okay, thank you. All right, so you are saying that in unsupervised learning no teacher is there. Okay, fine, I got. No, I thought it as I'm not there in the meet. All right. Sorry, actually confusing, sorry. So this data points are clustered into one group since they are closer to each other, and this data points are clustered into another group since they are closer to each other, and these data points are clustered into another. So we can form 3 clusters, and you can decide on the number of clusters you want. That can be done, I'll tell you. Okay, if you want 4 clusters, your data will be separated into 4 clusters based on the uh, distance between them. Based on the distance between them. Oh, it is what applied in the real world itself, right? You cluster the last bench students as last bench students and first bench students as toppers, right? Since they are closer to each other, and that's why they are called as toppers, and last bench students, they are closer to each other. And since last bench students are far away from the first bench students, you can easily distinguish them, or you can easily make them into two different clusters. That's what we mean by distance-based clustering, right? Distance-based clustering. Right. So yes, coming to Ms. Bhavana's point, in supervised learning, we call this learning as learning supervised by a teacher. Okay, the teacher is going to be your output, because since you feed the output as well, since you feed the output to the model, the learning is actually supervised by the output. Okay, you can calculate the error between the predicted output and the actual output, because you feed the actual output as well, right? So this is what we mean by learning supervised by a teacher. Whereas in unsupervised learning, it is not supervised by a teacher, because you have only the input, no output, right? Which is not well labeled. The output is not well labeled. So in unsupervised learning, so somebody says in unsupervised learning, it is not possible to identify or name the objective. Not at all. Actually, you can name the objective by yourself. You can name the clusters by yourself, but the model doesn't know. The model just classifies or clusters based on the similarity between the data or the distance among the data points, sample points. Am I making clear? Is it okay? Yes, yes, yes. So are these examples clear? Okay. Thank you, people. Thank you so much. So that's all about supervised, unsupervised learning. Coming back to reinforcement learning. So where I told you can, yes, yes, exactly. Objective is your output, right? Okay, coming. Okay, in this supervised or unsupervised, they are separated, identified by a common point, right? I don't get your question actually, Ms. Harshita. Okay, thank you, Ms. Bhavana. Thank you, ma'am. It is not like no separating by a common point actually. Or I'll give you some examples. Don't worry. I'll give you how the decision boundary is actually formed. We have 3 more days of workshop. Right? Actually, 2 more days. Don't worry. I think the next day should answer this question. Labels are all called as common point. Not actually. We don't have any term like common point. They are labels only. The outputs are labels or annotations maybe. You annotate that this is apple, right? You annotate that this particular fruit is apple and give it to the ML model. That's all. They are not common point. Actually, I hope you are saying this as common point, right? This is a cluster. Am I making clear? Yeah. Okay. 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 Common point. All right. So we will dig deep into it and we'll see what it is. Fine. So now we will come back to reinforcement learning. As I already told before, you connect the ML model directly with the environment, right? And you do some action and you get back the rewards for that particular action. Let us say I train a dog. Okay, this is a kind of classical example they will give. So let us say I'll train a dog to do some activity. Okay, so whenever the dog does the activity, what I intended for, I will reward the dog with a chocolate maybe. I'll give rewards to the dog. I'll appreciate the dog. Okay, and whenever the dog does some activity which is not intended, which is not good, I will penalize the dog by giving some negative rewards. So the dog is going to actually learn from the rewards what I give. If I give positive rewards for an activity, the dog will understand that and the dog will actually repeat the same activity since I'm giving positive rewards for it. Whenever the dog does some wrong things, I will penalize the dog. I will give negative rewards for the dog in some way. You can give negative rewards in any way, by either by, let not go into that, but you can give negative rewards. In that case, the dog will learn that, okay, so I'm getting negative rewards for this particular action, so I should not repeat this, right? So this is what we mean by reinforcement learning. You do one activity and get reinforced. You do an action, not activity actually, action. You do one action and get reinforced. Yes. So reinforcement learning is actually applied in gaming. Exactly. Thank you, Ms. Bhavana. In gaming, whenever we move from one state to another state, let us say I'm in this state now, S1. Okay, I can move to 2 different states by performing 4 different actions. I can neither go this way or this way. So this is one action and this is one action. So this will take to me to state 2 and this will take to me to state 3. And if I repeat this action A3 and A4, I have 2 more actions in this state. So if I go in this direction, I will reach the destination or winning point, let us say. If I go in this direction, I will go to some trap. Okay. So let us say I am in state 1. Can you tell me which action I should perform in state 1? Which action I should perform? A1 or A2? A2, thank you, doctor. A2, definitely. So A2, because so I have two set of actions in my action space. Only if I perform A2, I will go to state 3. And that will take to me the winning state, take this person to the winning state. If I perform action A1 and go to S2, eventually I'll fall into a trap. So I should not do that, right? I should not do that. Okay, so I have to make sure that whenever this agent, this is called agent, whenever this agent performs an action which is desired, which takes that agent to the winning state, I have to give more rewards to that agent. So I have to set a reward for these actions. So let us say for A2, I'm setting a reward plus 10, and for A1, I'm setting a reward minus 10. Then eventually S1 will perform the action plus which has most rewards, that is A2, right? So it will come into state 3. And once in state 3, I have two different actions to perform. Now, can you tell me which action I should perform, either A3 or A4? A3. So for desired actions, whether A1 or A2, that is what, ma'am. For A1, the reward is minus 10. I have to set the reward for it. For A1, the reward is minus 10. For A2, the reward is plus 10. So basically, for a ML model, the numbers matters a lot, right? So for A2, the reward is plus 10. So it will select A2. It will select the action which will give it the maximum reward, right? But if it takes A2, if it takes A1, let us assume that if it takes A1, I will give a negative reward, that is minus 10, what you see in the screen. So it won't take that action. If it takes A2, I'll give a positive reward plus 10. So it will give the continue that action. Am I making it clear? So everything is based on the rewards what you give, right? Is it okay? So you have to set the rewards before. You have to set the rewards before, and that's how we let the ML model to select the best actions according to the rewards. That's all. Very simple. Very simple. Rewards work here. Okay, and rewards can be anything. It need not be a number in a particular range. You can give any reward. Say, for example, in the winning state, if I give a reward like plus 1000, it will immediately take this action. Everything is dependent on the reward. And A4 gets me to a trap means I will give a reward like minus 100, let us say. So whenever if you give a positive reward, that means that is the desired action. It will take that action. That's all. So learning from rewards. Okay. So if it takes the desired action, you give the positive rewards. Otherwise, you give negative rewards and penalize it so that it won't repeat that action in the next round. Okay. Right? Am I making it clear? Okay. So shall we move on? That is reinforcement learning. Yes, that's reinforcement learning. All right. So as you can see here, you perform an action on the environment and get back the reward. And you observe the current state of the environment as well. That is called state. So you perform an action on the environment and you get the reward. If that reward is positive, you repeat the same action. Otherwise, if that reward is negative, you change that action. That's all. Very simple, right? All right. So now let us talk about the machine learning pipeline, in which we have several blocks. We have some different steps, which is best accurate ML algorithm. That's kind of a difficult question to answer because there is no best accurate ML algorithm. It depends on the data what you provide, right? So I told you in the beginning itself, the accuracy of an ML model, it depends on the quality and quantity of the data set what you give, right? So if the data set is going to be completely linear, right, then in that case, the ML model will be more and more accurate. Okay. So that depends on the quality and the quantity what you provide. If you give 10,000 samples to the ML model will have time to learn all these relations. So obviously it will be more accurate. That there is no algorithm like which is best suited. Okay. Is that answers? Yes, thank you. Right. So there are 5 steps in this machine learning model pipeline, which you have to follow in order to successfully build any ML model, right? In order to build any ML model, you have to follow these 5 steps. Okay. So the first step is Data collection. So forming the data set is the first step. Let me write all the steps and let me explain it one by one. Then the next step should be data pre-processing, right? And the next step is feature extraction, right? Fourth step is yeah, sir. That comes under data pre-processing. Let us take it like that. Okay, so we have to clean the data basically. That's what I'm going to talk about in data pre-processing and training the ML model. Training the model. Training the model involves creating the model as well. So don't ask me to include that as a separate step. Okay, so training the ML model basically involves creating the ML model itself and creating and training the ML model. Then we can do the testing, or you can call it prediction, and you can even call it, and you can do the deployment as well. That's kind of an optional step, right? So now I'll explain it one by one. So please listen. I hope you have noted down all these steps: collection, pre-processing, extraction, training the ML model, test, prediction, and deployment. So transformation will come into picture. If you want, you can use transformation as well, and that comes under data pre-processing. Right? Scaling or normalization, scaling, and transformation techniques. All those transformation techniques, you can put them under this second block, data pre-processing. Again, if you look at, there will be n number of blocks, but this is how we generalize them: data collection, data pre-processing, feature extraction, training the ML model, test, prediction, and deployment. Okay, so now let me explain it one by one. The first thing is data collection. First of all, you have to identify the problem, what you are going to solve using ML. That's the first thing you have to do. Say, for example, if you are going to build an house price prediction model, you are going to collect data related to that, right? In that regard, you need to be a domain expert, because or you have to be connected with a domain expert to collect the real-time data. Okay, or you can even collect the data from open source websites as well. Some websites like Kaggle, which should give you the open source data sets available for any problem. Okay, so somebody would have collected the data set and made it available in the internet. Okay, you can use that data set. That is possible. Otherwise, you can generate your own data. So that is there. Okay, so that's the first thing, data collection. You need to collect a lot of data, lot of samples, right? So that is very important, because I told that definitely, ma'am. Yes, ma'am. You will get the PPT and recording. Okay, coming back to this data collection, the domain knowledge should be there, right? So when you are building an ML model, I mean, for let us say for predicting the flight delay, then you must be knowing all the aspects of the flight, why it is getting delayed, on what factor does the delay depend on, right? So you have to collect samples regarding to that. Okay, the more the data, the better will be the algorithm, and that answers your question, Mr. Khan, which is the best accurate ML model that depends on the accuracy or the quantity and quality of the data, right? So the second thing is data pre-processing. Can you tell me, is there anything wrong with the picture what I have shown in the image, or what I have shown in the slide? Is there anything wrong? Color of front fruit. So technically it is an outlier, and non-technically there is one fruit which is red in color. So both the answers are right, actually. Yes. So the one data sample, the red color apple, one data sample which doesn't fit to your data set is actually called as an outlier. And there is a mathematical procedure to remove that outlier. You have to make sure that all the outliers are removed. That will make your ML algorithm more and more accurate. But why outlier is making the ML algorithm inaccurate? If I want to answer that question, see, I am going to label these data as green apple, and I'm going to make the ML model learn that particular thing. It's like this is going to be the green apple. If I include one red apple, the ML model will assume that this is also a green apple, and it will learn, a irrelevant classification, that is right. So that is actually an outlier. So the prediction will go wrong if you use that, right? So if you actually include this in the data, the prediction will be wrong. So you can call this red color apple as a outlier, which doesn't fit to your data set, or you can even call it as a noise, right? So you have to remove this. I'll tell you the mathematical way to remove the outliers, right? So, but that has to be removed. And you have to make sure that there is no missing values in your data set as well. If there is any missing value, you have to remove the entire column, or you have to replace the missing value. Fine. For example, okay, in pick we can easily identify, but how we identify in large data? That's why I'll tell you the mathematical procedure. This is we have some statistical formula to identify them. I'll tell you immediately after this slide. Don't worry. Will that be okay? What is extreme point? Extreme point is kind of different things. Actually, we usually call extreme points are points which lie closer to the decision boundary, which I'll explain that later. So when it comes to the decision boundary, right? So okay, color of pixels different. Yeah, that is very straightforward. Okay, we can identify, but so that's an outlier basically. So one thing that doesn't fit to your data set. But let me tell you what is a missing value and what can be done with that. So the example what we have taken is area, locality, price. Let us stick on to that. So price is y, x1 and x2. What do I mean by missing values? Let us say I have 50, 150, 200 square feet. In square feet, you just take the scale in square feet, and I have a missing value here 300, something like that. And locality is 1, 2, missing value 3, 4, something like that. Locality should actually be a urban, semi-urban, rural, something like that, but I'm encoding it in numbers. That's all. And the price is 50 lakh, 100 lakh. You take some random prices, 150 lakh, 200 lakh, 300 lakh. So there are two missing values in this data set. One is this and another one is this. So you can do different things in order to tackle those missing values. One thing is you can remove the entire rows. So you can remove this row and you can remove that this row is asking. That is one way. But the problem here is that will reduce the amount of data you have. If you keep on reducing all, if you keep on removing all the rows which have missing values, then you are going to get, eventually you are going to get a very less amount of data, right? So that is a problem. So, but one way is removing the entire row. Okay, to tackle the missing value is one way is removing the entire row. So if you remove the entire row, the missing values will go off, but that will reduce the amount of data set, right? The quantity of the data set, right? Yeah, that's the next step. Thank you, Ishit. So the second thing is you can either replace it with some values, right? What kind of values? I can replace it with the mean of this particular column, right? Mean, exactly. Thank you, Ms. Vijay Pathasarthi. I can replace it with the mean, that's the average value, or I can take the median as well, or even I can take the mode, right? Median means the center value, the middle of that particular range, or mode is the more number of times, the value that occurs for the most number of times, right? If I say that 3 occurs for most number of times, I will replace this missing value with 3. Okay, so I will look at the entire column. Either I'll replace that missing value with the mean value of that column, or the median value of that column, or the mode value of that column, right? And the same applies for this column as well. So with respect to the column, I can find the mean, median, or mode, and I can replace those missing values. That's the next thing. The advantage here is you are not going to reduce the quantity of the data set. The data set size is going to remain the same. But what's the disadvantage in this case? Can anyone tell me? If you replace those missing values with mean, median, or mode values, what is the disadvantage and what is the limitation here? Anyone? Exactly, doctor. Thank you. So those are not the exact values, right? Those are not the exact values. Those are some assumptions what you have made. So if just because you're replacing that missing value with mean or median or mode, that doesn't mean that that is your actual value. The actual value what you have taken, the actual reading what you have taken, that is not there, right? You are just replacing in order to you are assuming that okay, so this is somewhat closer to the right answer. You are assuming like that, and you are replacing. But nevertheless, you have only these methods, right? So that's how you handle missing values. So all these kind of stuffs have to be done in the pre-processing stage, what we are talking about right now, right? So that's how you handle the missing values. Am I clear in this? Is it okay? Yes, yes. Is it possible to find mean, median? Yes, definitely, definitely, right? Uh, it is possible. You can simply write one line code that will find the mean for the entire column. I will teach you that, don't worry. Okay, so based on the mean, we can extract and identify the outliers. Not actually, not based on the mean. We will extract and identify outliers based on the median. Okay, I'm coming to that. Why, Ferry? I'm coming to that. Okay, so what is the accuracy we'll get in ML? That depends on the data set, again. So if you have a data set which is very linear, okay, so let us say if I increase the area, the price will get definitely increased. There is no row which is an exception, that is for that row, if the area is less, the price will also be price will be greater. If there are no exemptions or exceptions in my data set, if the relationship are exactly linear, if the relationships are exactly accurate, then the ML model will also be accurate. That means you have to remove all the missing values, you have to remove all the outliers. So the accuracy depends on the data set only. Okay. If the data set is too clean, if the data set is very linear, you will be getting more accuracy. If the data set is not linear, if the data set contains too much noise, too much outliers, too much missing values, then the accuracy will get affected. Uh, uh, I am comfortable in English, thank you, because many people, I think they won't be understanding Tamil here. If my English is poor, please tolerate. I'm sorry. Yeah, thank you. All right. So, thank you, people. Thank you, gentlemen. So, okay, thank you. You guys. Thank you. Right. I think it's 8, 9. Time flies like that. I think we should take a break now. Okay, thank you, Hashita. We should take a break now, and we'll come back at 8:20 sharply. We'll take a 10 minutes break, and we'll come back at 8:20 sharp. We'll continue the session after that. Okay. Thank you, gentlemen. Thank you. Hey people, welcome back. So the discussion is very healthy here. It's a very interactive environment. I'm very glad to continue. We are good to go, right? Everyone here? Yes. Thank you, people. Right. So we will continue on that. So we have been discussing about the different stages in the machine learning pipeline, right? So initially we talked about data collection. Now let me present my screen. So initially we were talking about the data collection part, right? So where you collect the data from domain experts, or you can even collect the data from the internet, open source data set websites, right? So we then moved on to this one, data pre-processing, where we talked about the missing values as well as the outlier. So missing values are pretty straightforward to find out, right? So by just iterating through the data set, you can find out where the missing values are, and you can easily replace those missing values by mean, median, or mode, or you can even remove that entire row. That is very straightforward. And you have this concept called as outliers. Let me tell you how to find out the outliers through a mathematical way. So listen carefully. Fine. Uh, let us take some data points like this. Need not be sorted always. Data set can be of any order. Can you tell me the outlier in this set of data points? Yeah, it's straightforward. By seeing the data set, you can easily say that the 65 is outlier because it's somewhat lying outside the range, right? Okay, let me put it in this way. 1, 2, or take an unsorted array. 4, 6, 2, 3, 5, 1, 8. Can you tell me the outlier here in the second set of data points? 4, 6, 2, 3, 5, 1, 8. 8. Okay, 1 and 8. Okay, any other answers? Thank you, people, for giving me those answers. But any other answers? 3 and 5, no outlier. 8 only. So I'm getting interesting answers. 1, 3, 5. Okay. All right. Thank you. Let us reveal the answer. Actually, 7 missing layer. Okay, that is not 7. No, you don't think of sorted array, right? So you don't look for should not look for missing values actually in this particular data points. I'm giving a set of data. These are my data points available, and I'm asking you the outlier. That's all. No, there is no need to look for missing values. Okay, so in these set of data points, let us see whether there is an outlier or not. So in this case, it is very hard to decide. That is my point. It is very hard to decide whether there is any outlier, or if that exists, what is my outlier actually? It is very hard to decide, right? So there should be a mathematical way which will tell us what are those outliers, right? What's your parameter? Oh, let us assume something, some feature which has these data points. That's all. I am now concerned about finding out the outlier, not about the parameter. Okay. Right. So now, ma'am, I think you're asking me the parameter with respect to I'm finding the outlier, right? Not actually. Since it is not continuous, no, that is not the correct discussion. No, I'll tell you the condition. First of all, listen carefully. Let us take this range. Let me tell you a procedural step in order to find out an outlier, right? So let us take the same data points, 4, 6, 2, 3, 5, 1, 8. Okay, 4, 6, 2, 3, 5, 1, 8. Okay, the first step in identifying an outlier is sorting the data points. So first of all, you sort the data points in ascending order, right? You sort the data points in ascending order. Okay, so 1, 2, 3, 4, 5, 6, 8. If I saw this data point in ascending order, this is how it should look like, right? So this is the first step in identifying the outlier, right? Once you have sorted down the data points in the ascending order, what you have to do is you have to find out the median of this data points. Second step is to find out the median. Can you tell me the median of this set of data points? Median? Anyone? 4. Thank you, doctor. 4 actually. Thank you. So 4 is the median, right? We will take 4 as Q2, right? Let us call it Q2. And let us now divide this data point two different ranges based on the median. 1, 2, 3 is one range, and 5, 6, 8 is another part, another half of the data points, right? Can you tell me the median in the first half? Can you tell me the median in the first half? 2. Thank you, people. This is Q1. Okay, this is Q1. And similarly, can you tell me the median in the second half? 6. Thank you, people. That's going to be Q3, right? That's going to be Q3. Okay. Now, you have to identify the difference between Q3 and Q1. That's the third step. After identifying the median in the first half, the median in the second half, and the median of the entire data points, that is Q1, Q2, and Q3, you have to identify the difference between Q3 and Q1, Q3 minus Q1. This you call it as interquartile range. Okay, interquartile range. Basically, Q1, Q3, Q2, they are called as quartiles or the medians. Okay, quartiles or the medians. So, Q3 minus Q1 should give you the interquartile range. Interquartile range. Clear? So IQR is 4, right? I don't know why it is going. It's not going down. Give me a minute. Yes. So IQR, what is your IQR? Interquartile range. That is going to be Q3 minus Q1. So 6 minus 2 is 4. Thank you, people, for answering this question. All right, so it is 4. So IQR is 4. Now you have a defined formula. Your allowed ranges. Once you have found out the IQR, the allowed range look like this. This is a mathematical formula. Allowed ranges Q1 minus 1.5 times IQR, comma, Q3 plus 1.5 times the IQR, right? So Q1 minus 1.5 times the IQR, comma, Q3 plus 1.5 times the IQR. This is the allowed range of your data set. And this is kind of a standard formula which you can apply for any IQR and median and same. Not always. They can be different for some other data points. For this data points, maybe they are same. Okay. Okay, come back to this range, allowed range. Q1 minus 1.5. That is the standard definition or that they have arrived through some mathematical derivations, Ms. Kritika. Basically, we are considering a part of IQR. So what is that part? 1.5 times. Okay. And if I take the derivation, that will go for another 1 hour. Let us not go into that. Okay, so we are taking a part of IQR. That's all. So Q1 minus 1.5 IQR plus this. Can you identify this range? Can you please find out this range? So Q1 is. Can anyone find out this range? IQR is 4. IQR is 4. Q3 is 6. And Q1 is 2. Substitute that and find out. Minus 4, 12. Is it actually 12? Okay, so Q3 is 6. Okay. So got you. Thank you. Minus 4, 12. Okay, so 4, 1.4. Thank you. It is 12 actually. Minus 4, 12. So now this is your allowed range for this data set. So you have found out the allowed range. So it is minus 4, 12, right? Minus 4, 12, right? So you have found out the allowed range, minus 4, 12. Now you have to check whether all these data points lie in this range. If any of the sample lies out of this allowed range, that is actually the outlier. You got it? That is actually the outlier. Can you tell me which sample is actually lying outside this range? Can you tell me which sample is actually lying outside this range? -4 to 12. So your timeline can be from -4 to 12. So can you tell me which sample is lying outside this range? Nothing, no outliers. Can you repeat again there the last point? See, uh, you find the IQR basically. You sort the array first and you find the IQR. The first half is Q1 and the second half's median is Q3. So Q3 minus Q1 gives you the IQR, interquartile range. Once you have got the IQR and Q1 and Q3, from the data points, you are going to find Q1, Q2, Q3 and IQR. It's very simple. Q2 is the median, Q1 is the median of the first half, and Q3 is the median of the second half. Once you have got everything, you just substitute in this formula. That's all. That will give you the range, -4, 12 in this case. You substitute Q1 as 2, IQR as 4, Q3 as 6, and IQR as 4. So that should give you the range, -4, 12. Now, once you have got that is the allowed range. You have found out the allowed range. So once you have got the allowed range -4, 12, it is actually -4, 12 only, right? Because I don't know. I haven't calculated by myself. Many people say that it is -4, 12. Or do you want me to calculate it? Need not, right? It is -4, 12 only, right? Yes. I believe in you. Okay. Non-numerical? No. You have to encode it, Irshad. You have to apply some techniques in order to encode the text as numbers. Anyway, at the end of the day, you are going to give them as numbers to the computer, right? Okay. So you have to encode them as numbers. Encoding is like converting those text into numbers. Okay, that have to be numbers because numbers can be trained with computers. Computers work on numbers. Without them, it is not possible, right? Fine. So in this case, this is the allowed range, right? -4, 12. There is no data point which is lying outside this allowed range. You can clearly see that here. 4 is within this range, 6 is within this range, 2 is also within this range, 8 is also lying within this range, right? There is no data point. If you have a data point like 65, that is definitely outside this range. So that is basically my outlier. So there is no outlier in this set of data points. There is no outlier here. Am I making it clear? Is it okay? Is it okay for everyone? Do you find any ambiguity here? Is it okay? Yes. This is one way to find out the outlier. And this is not the only way. You please keep that in mind as well. This is not the only way to find outlier. This is just one of the ways to find outlier. And if I discuss all the ways to find out the outlier, and that goes as a separate subject, applied data science, right? So we are concerned about machine learning here. So let us touch some aspects of data science and come back to machine learning, right? So you just remember these steps. You have to sort the array, find out the medians, right? Yeah, we will do that, Ishit. We'll do that actually. I'll tell you. We have that is actually included in the session itself. I'll tell you. Don't worry. Okay, coming back to here, we have to sort the array first of all, sort the data points, find out the medians, and get the IQR, interquartile range, and use this formula to find out the allowed range and check whether any data point is outside the allowed range. If that data point lies outside the allowed range, that becomes your outlier. That's all. Very simple. So that's how you find out the outlier. Okay. The third thing is feature extraction. It's a very, very important step, right? It's very, very clear that you are not going to give this image as such to any ML model. Okay, you cannot give an image directly to any ML model. You have to extract features from the image, and you are going to give only the features, right? Can you tell me some of the features which can be given in case of a fruits classification model? If let us say you want to build an ML model which will classify the fruits, whether it is apple or orange or banana, you show it an apple, it will classify that as apple. Yes, so those are going to be your features: color, size, shape. Those are going to be your features. So extracting those features from the image, if you want to extract those features, right, that step is actually called as feature extraction. Okay, So extracting the information, the useful information from those images is actually called as feature extraction. Nowadays, there is no need to do the feature extraction manually. Okay, there is no need to do the feature extraction manually. You can directly give the image. The ML model itself, an interesting part of the ML model will actually extract feature. It's actually a deep learning model. Can you name it? Can you name it? You can directly give the image. You let the machine itself extract the features and learn it. Can you? That's one interesting area that most of the people work on. Any image processing application, any object detection application, not OpenCV, OpenCV also, but in that case you do it manually, right? Okay, DL, that's clear. What, in which aspect of DL you do that? What type of deep learning model? I'm asking. Okay, neural networks, pretty closer to the answer. What kind of neural networks, ma'am? What type of neural network? Let me put it this way. CNN, thank you, ma'am. Thank you, ma'am. It's CNN, convolutional neural networks. So in CNN, you have some extra layers called as convolutional layers. So you pass the image to that layer. That layer will actually extract the features from the image. It doesn't have anything other than that to do. Okay, it will only extract the features, and that features will be again given to a neural network. So that will learn the features. So that process of extracting features is actually called as convolution. Okay, though I'm not covering that in this course, there is a high possibility that we may get a sequel to this course in February or March. In that case, we will cover the aspects of deep learning. Okay, so as of now, many people, you might know that convolutional neural network is used for image processing, where you can give the image directly and get the features and make the ML model learn. Otherwise, if you use the conventional ML, you have to extract the features and give it to the ML model. If you use CNN, it will extract the features by itself. You just need to give the image. Clear? Difference between traditional ML model and CNN? Is it okay? Okay. Okay. So feature extraction must be done manually in case of machine learning. But in case of deep learning, especially in case of CNN, the feature extraction will happen by itself. That is the idea. So that is where DL has an edge over ML. Is it okay? Yes. We'll move on, people. So the third step is, the fourth step actually. The first step is data collection, pre-processing, user extraction. You have training and prediction. So once you have got the data, you have cleaned the data, you have removed the outliers, you have extracted the features as well. In that case, you can start the training of the ML model. I will tell you how this training happens. Right? This is the actual algorithm part. Right? So you have set of algorithm similar to what I have told for outliers. There is a standard procedure, right? So you just have to apply that procedure and to learn the data set. That is what we mean by training. So training means learning the data what we give to the ML model. The machine will learn the data what we provide, and once it has learned the training data set or the data set what we give, it can do the predictions since it has got the inferences, right? So that's the next step. First step actually doing the predictions, right? So those are the 5 steps. I wish you got it right. Okay, so these are the machine learning terminologies. The data set, that is very important. You should have the data set in hand, where it will contain all the samples related to the problem what you are solving. Should be related to the problem what you're solving. And you have to split the data set into 2 different parts. One part is going to be the trained data, which you can use it for training, and another part is going to be the test data, which you can use it for testing. I'll talk about that in a while. I'll talk about that. Then you can have this term ML model or algorithm. We will basically call any machine learning system what we build is actually a model, right? We call it as a model. And libraries, there are a lot of libraries involved which you can use in order to build an ML model. And the prediction is a word that comes into play once the ML model has learned the data set. right? So prediction is actually forecasting the output, right? Actually identifying the output whenever an unknown input is provided. The input for which the output is not known, when that is provided to the ML model, the ML model will do its prediction and give us the answer. Accuracy is a factor. It's a very, very important factor, because the ML model will not always do right prediction, guys. Okay, so there will always be an error. There will always be an accuracy factor accompanied with an ML model. So whenever we talk about an ML model, we talk about this accuracy. And there are several factors on which the accuracy depends on. So we'll talk about those factors later. And the pre-processing techniques, we will discuss on that. So these are the basic terminologies. I hope now we are very confident about these terminologies. Okay, so that's all about my presentation. Now we will actually jump into the Pythonic modules that we have to use for ML. Before that, let us have a quick quiz on what we have learned so far. Okay, so fingers on the keyboard. Now, the first question is, so identify the type of learning in which labeled training data is used. Straightforward, directly from what we have discussed. Thank you. That's all. A. Okay, I got an A here. Okay, thank you. Semi unsupervised. There is no classification called as semi unsupervised learning. It's wrong. Thank you. Almost all of you got it. Okay, machine learning is a subset of which of the following? It's a rapid fire round. You have to be very, very quick. Machine learning is a subset of artificial intelligence. So this is what I told. It's not a subset of deep learning. Deep learning is a subset of machine learning. You try to differentiate. Deep learning is a subset of machine learning, whereas machine learning is a subset of artificial intelligence. Yes, thank you, people, thank you. Learning from rewards, a very straightforward, no-brainer actually. Learning from rewards is reinforcement learning. Thank you. I got a B, I got a A. Please avoid. I hope those are no typological errors. Predicting whether a particular person's I haven't discussed about this. Let me go back. Right. So whenever yes. Okay. Whenever a problem is given to you, you should be able to say whether that is a classification problem or a regression problem. Okay, let me tell what regression is all about. Okay, regression is making a prediction of continuum of values. Okay, regression is making a prediction of continuous set of values. That means you are predicting a particular value which can lie in the range of -infinity to +infinity. And you can have floating point values as well. You can have decimal points values to be more naive. Okay. For example, predicting a house price, predicting the house price is actually comes under regression, because there the value is going to be either 50 lakhs or 50.385, 65,585.767. So wherever you get those floating points and you have continuous of values, the values can be anything, right? The values can be anything in the range of -infinity to +infinity. If that is the case, that is going to be regression problem. Another example could be predicting the number of corona cases. Maybe the value can be anything, right, from 10,000 to 1 lakh. Okay, so that making prediction in that case, in a continuous set of values from -infinity to +infinity, that comes under regression. Yes, parametric data. Thank you, sir. So that comes under regression. So given a problem, you should be able to identify whether it is a regression problem or not. Whereas in other terms, we have classification problem. So in classification problem, the output is going to be categorical, right? So output is going to be categorical. That means the output should be put in any one of the categories. Output should be put in any one of the categories. So we have several defined categories. You can only put the output in any one of the categories. The output cannot be from -infinity to +infinity. The output cannot be a point value. The output cannot be a decimal value. Cannot be a floating point value. It should be put in any one of the categories. For example, if I have a dog cat classification problem, I have to predict whether an animal is dog or cat. In that case, I have only two categories, whether that animal has to be put in dog or cat. That means output can be either dog or cat. Output cannot be some value. It should be either dog or cat. That's all. It should be either 0 or 1, right? Or if I take a fruits classification problem, the output must be either apple, banana, or let us take 3 fruits. Okay, so the output must be either this or this or this, right? Apple, banana, or orange. It cannot be a value. Okay, of course, these are numbers only. Let us encode apple as 0, banana as 1, and orange as 2. If that is the case, my output can be either 0, 1, or 2, categorical. Output can be either 0, 1, or 2. It cannot be 0.5 or 1.5, right? So this kind of problems are called as classification problems. Whereas predicting the continuous set of values comes under regression problems. So regressing is something actually known as extrapolating. I'll talk about that when it comes to linear regression. But as of now, we have to be very confident in this. Is it okay? Is it confusing? Distinguishing between regression and a classification problem. Welcome, sir. So humbled and honored to have you. Thank you, sir. All right. So I think if this is clear now, you should be able to answer this question. Yes. Predicting whether a particular person has diabetes or not. Definitely, it is a classification problem because you are going to have only binary value, right? It is going to be either either having diabetes or not having diabetes, 1 or 0, right? So it is a classification problem. You are going to classify whether the person is having diabetes or not. This is not a regression problem, right? Object recognition comes under classification, regression, clustering, both 1 and 3. Okay, getting multiple answers here. Okay, let us stop with those. I'm getting only these. Obviously, that must be the right answer. Actually, object recognition is where you recognize a particular object and tell what it is. You assign a label to an object. That is what we mean by object recognition. We let the ML model to to recognize that this is a pen, this is a pencil, this is a board, this is a water bottle, something like that. So if we give the data in labeled manner, if we take 100 samples of water bottle and if we label that as water bottle and give it to an ML model, that is classification. That comes under supervised learning. Okay. And if we give 100 samples of water bottle and we are not naming it as water bottle, we are not labeling it, right? We are not labeling it. The ML model should form clusters based on the similarities, what we have discussed a while before. Based on the similarities, it should form the clusters, right? In that case, clustering is possible. So both are actually possible, right? So that is the point. I hope many people got it right. I'm very, very glad. Thank you. Is that answering your question, Ms. Ashita? What is clustering? We are grouping based on the similarities where we don't provide the labels. Is it okay? I think I've discussed it. Yes, thank you. Most fundamental requirement for any ML-based system is dash. It's an open-ended question. Open-ended, you can give multiple answers. Glad, ma'am, glad. Thank you. Data set. That's the answer I'm looking for. Thank you, Mr. Apsal, Kritika, Shruti. Thank you. Features. That's the other way you can put it on. Features are also right. Data set. Super. Because the quantity and the quality of the data set is going to dictate your accuracy. Right. So information. That's the other way you can put it on. Data set is kind of a technical term that we use. The technique of using statistical procedures to learn the patterns in the data is dash. Not big data, definitely not. Big data is you have a huge volume of data. You have a very huge volume of data that should obey three different properties, right? Variety, velocity, and volume, if I'm not wrong. And that is not covered in this course. Sorry. Any big data should obey three different properties. It should have variety of features, variety, uh, volume. It should have a huge amount of data, volume, and we should be able to take the data, take the readings at a very high rate, velocity. So it should obey three different features. Big data, and we are not talking about this is machine learning. Thank you. Very straightforward definition of machine learning. Technique of using statistical procedures. Thank you, you guys have been very attentive. Technique of using statistical procedures to learn the patterns in the data is machine learning. Thank you. Regression is also the right answer. Regression is a part of machine learning. Okay. Great. I hope most of the people got everything right. Thank you. I'm very glad. Okay, we have 9 more minutes. Let us not waste those 9 minutes. I'll start a new topic, and when we come back tomorrow, I'll just resume from the point where we passed. Right. So now I think we have got a hang on the basics of ML. We have got a good hang of it. Now we have to try to implement those ML algorithms in Python. Before that, we have to learn the algorithms as well. That has to be done. We have to learn the algorithms. We have to know what are all the algorithms, and we have to learn that. And we will try to implement that in Python, right? So it is not that you can implement machine learning only in Python. You can use R as well. You can use MATLAB. You can use any language to implement ML. There are good languages which provide the support. I know Python, and Python is known to be the fastest growing language in this decade, and also Python has a very good support of data science toolkits which you can use for ML. So that can be done. I haven't planned anything, ma'am. Maybe I'll plan it and I'll assign it as a task in the WhatsApp group. Sure, ma'am. That can be done. Actually, only after teaching the algorithms tomorrow, I can assign the task, right? What we have seen is just concepts and terminologies of ML. From this, I cannot assign any task. Yes. Okay, so let me teach the algorithms tomorrow, and the implementation can be actually done as a task. I'll show you one example implementation, and I'll give you that notebook to you, and you can take that notebook as a reference. You can take your own data set and build the project. Build the project using the reference code what I provide. I'll explain each and every line of code I write. You can use it as a template, which you can use it for any ML model which you build in the future. I'll tell you 10 to 15 different steps which you have to keep in mind whenever you are approaching any ML problem. Okay, so let us not waste these 7 minutes. Coming back to this implementing ML algorithms in Python. So Python provides support for implementing ML algorithms used through several libraries. One such library is NumPy, Pandas, Matplotlib, and scikit-learn. There are several other libraries as well. Okay, these are some of them. So I'm talking about the data science and machine learning libraries. Okay, don't tell me about TensorFlow and Keras. They come under deep learning libraries. Okay, so this is NumPy, Pandas, Matplotlib, and sklearn. Now I'm going to ask you a very important question that is going to drive the session further. Okay, so I have to restructure the session in such a way that that eases your learning, right? That means you have to be comfortable in the two sessions that are going to come in the future, right? So on a scale of 10, how much would you rate yourself in Python? On a scale of 10, please rate yourself in Python. 5, 10. Great, ma'am. Great. 5, 5, 5, 5, 2, 5, 6, 1. Okay. Thank you for being honest. 4, 7, or 1. I could see several ones, eyes, and 7. I thought I could restructure the session in such a way that you guys are comfortable in Python. So, shall I directly start from NumPys and revise the Python concepts wherever required, or do you want me to start from the print statement, that is the while loop, for loop? Great, ma'am. So proud and glad to have you here. Should I start from the loops if conditions, or shall I directly start from NumPy? Yeah, okay, okay. Yes, yes, yes. Thank you, people. Thank you, gentlemen. Thank you. Yeah. Sure, sure, man. Yeah. Yeah. So we'll start with Pythonic libraries. Yes, yes, exactly, man. That's why we are planning for a sequel in February and March to this ML workshop. Actually, what you guys are attending now is the first installment of the series. We are planning for a series of workshops in machine learning. Yes, exactly. So we'll start with ML coding. Yes. Actually, I've conducted the same workshop as a 2-day full-time workshop, 18 hours workshop at PSG College of Technology a month before. It was an offline workshop, and it was received well by the audience. That's why we are conducting it again now. Yeah. Sure. Yes. Yeah. 18 hours cannot be in online, right? We cannot do an 18-hour workshop in online. No, my laptop won't be able to tolerate that. Actually, yeah, we'll do that. We'll try to plan something. Yes. Yes. We'll look for all the possibilities, Mr. Vishal. Sure. Okay, ma'am. I think since you're a Python trainer, I can go with some advanced concept. But you know, to connect with a lot of audience, I think I should start from NumPy basics, right? Will you be okay with that? Yes. Thank you so much. Yes. Okay. I think 2 minutes left out. That's all. I think I should end the session now. If you want to, if you want to know more about me, you can just go to Google and search Sujit Kumar MA. It should show my Udemy profile, GitHub profile, LinkedIn, etc. So you can go to this Udemy link, and you can have a look on the courses what I'm teaching, where I have around 34 courses. Yes, I'll post the link in the group. Okay. So if you want, you can buy some of them and learn. And I should be able to provide a discount as well, if you ask me. Yes. All these courses are high rated. So you can see the VLSI design is the highest rated course in the platform itself. It has a rating of 4.7. Yeah, sure, definitely. Analog circuits is also high rated with 4.6 rating. Machine learning is also there. So every aspect of programming is covered. Yeah, thank you so much. Would be happy to hear your feedback before you leave. Thank you, people. Very honored and humbled to be here. Actually, thank you.
Yeah, I guess it's done for the day,
Yes,
right,
ma'am. Yes, ma'am.
Sujit?
It's done.
Yeah. I was also listening few of that. It was really good.
Thank you, ma'am. Thank you.
Mm. Hope people also, the good knowledge transfer happened today, right? Anybody would like to give a verbal feedback for the day
Yeah,
one?
I should be happy.
Yes, people, anyone at least from the forum, one verbal feedback. Yes, 2 hours he was talking. At least for a moment of 30 seconds, someone can speak, right?
Hi, I'm Vishal.
Yes,
Sir, it was a
Vishal.
wonderful, wonderful session, ma'am. Like,
Yeah.
I like the way he explained, and like his language was good, so that we could understand easily. And the thing is, like, he went from the basics. Some like I know statistics, nothing
Mm,
much else. So like,
mm,
it was very interesting for me to learn all these things. And
mm.
if possible, it would be fine if you arrange. Total workshop on it, like on offline or online, anything is fine.
Place
Like,
you off from Vishal.
I'm from Chennai only, but now
Yes,
I'm at,
but Sujit in Coimbatore right now.
it's okay, fine. Anything is
Yeah.
fine. Learning, we can do
Yeah,
from.
understood. But we plan some open program
Yeah,
later.
yeah,
I'll definitely keep you posted.
yeah, sure. Thank you.
Yeah.
Thank you so much, sir. Thank you, sir.
Thank you, sir. Thank you so much. Very happy to hear that. Thank you.
Yeah, welcome.
That's all for the day one. And don't worry, I'll share you the recording for the day. Once it is processed, I'll share you the recording through mail as well as in WhatsApp. The link I'll share you in WhatsApp. Okay. So good night, all. See you tomorrow, the same
Uh,
time.
Very good night. Thank you, people. Thank you. I get some excellent feedback in the comment section. Thank you.